12th graders. So we are dealing today with finding integrals, but more specifically finding something that's called a definite integral. So as you can kind of see below, we're still dealing with our integral notation, but now we're adding these little numbers. And these little numbers create boundaries of which we are caring about the integral only between this value and this value. So if we wanted to look at like a big idea of indefinite versus definite, what we've been finding so far is indefinite integrals. And so you'll notice if you go back to your resources page that all of these are called indefinite integrals for 14.1. So an indefinite integral is the area under a curve. More specifically, all of the area under a curve, reminding ourselves that is what integrals are in general. Integrals are always the area underneath the curve, whereas derivatives were always the slope of the tangent line. Integrals are always the area under the curve. So if I wanted to draw the idea of any kind of function, let's do like a cubic that looks like this. It is all of the area underneath this curve. As it goes on infinitely, the area is infinite, all of this area, right? And so it is an infinite amount of area, so kind of hard to calculate. And so what that means is that it's just your integral of the function, and it's just an equation. So what that means for you mathematically is it's just an equation. That when you find the indefinite integral, it's just an equation. No more plus c. We solve for c by plugging in points, but we get this equation that represents this area, or sometimes acceleration, or sometimes velocity. And it goes on infinitely. Okay, so hopefully we can kind of think about this now, that a definite integral is a specific area under a curve. So if we go back to that cubic that looks like this, let's say I wanted to find the area between this value and this value. So I wanted to find this area between A and B. So it's a specific area underneath the curve, not just all of the area under the curve. How we notate that is still your integral. We start at A and go to B. So from this number to that number, notice that the bottom number is always less, right? 0 is less than 2, 3 is less than 6, -1 is less than 1. So we start from that x value and move to that x value of the whatever function. What we need to do is we need to find the specific value, we'll call it uppercase F of B. So we find the integral function, and then we plug in this number in for that integral, and we get a number here. And then we just subtract out the value when you plug in A for the integral. So uppercase F of A, right? So just that idea of once you find the integral, you plug in B for the integral and get a number. You plug in A for the integral and get a number, and just subtract them out. And that's how you find it. So what we get is a number, right? So instead of an equation for definite integrals, we get a number. So in the bare essentials, when you're asked for a definite integral, you end up with a number. And it's finite. It is specific, which is why we can get a number. All right. So the idea, the notation, hopefully we've got it, but if not, we've got a ton of practice. So we're going to find the value of each definite integral. So our first step with finding the value for finding a definite integral, our first step is that we just need to find the equation. EQ for equation. So if we wanted to find the equation for the integral of 3x squared, we would do 3 and then x cubed would make it 1 over 3, and then plus c. So that's just x cubed plus c. So hopefully that's kind of coming back to us. Take that coefficient out, raise that exponent up to 3, and then divide by that new exponent, and then that plus c at the end. After we find the integral equation, we then evaluate that integral from 0 to 3. And now you'll start seeing this notation a lot of this like bottom up kind of thing, from 0 to 3. So that will kind of show you that that's kind of what we're going for, is starting at this number and going to that number. What is the evaluation there? And so following this right here, we're going to plug in the top number first into our integral. So we're going to plug in 3 first into our integral. So that would be 3 cubed. And we don't have anything for c, right? C is not x, so we can't plug in 3 for c. So we just leave c like that. And then we subtract out and we plug in the lower value into our integral. 0 cubed plus c. Distributing that negative to both pieces, we get 3 cubed plus c minus 0. Oh, let's do 3 cubed as 23. Oh, no. Okay, sorry. This is, hopefully you've caught on. This is supposed to be to 2. So sorry. So this is supposed to be to 2. So from 0 to 2. So then this would be 2 cubed. 2 cubed is 8. So I just accidentally wrote 3 here. I think it's because I got confused with the cubed. So just keep that in mind that I just miswrote the upper bound here. That's my bad. So sorry. So then 2 cubed would be 8, minus 0, and then minus c. I want you to take note here that as we add c and then subtract c, they cancel out. And all we're left with is 8 minus 0, which is 8. And that is the value of this definite integral, the area underneath the curve of 3x squared from 0 to 2. So let's try and think about that here. 3x squared would look like this. So from 0 to 2, the area under the curve would be 8. That is the area under there. So that's kind of cool. Notice also that since those c values cancel out, we really didn't need them to begin with, which means finding the definite integral, finding these values, while yes, plus c is a part of this equation and we don't know what it is, we actually don't need to know what it is because it cancels out. So you'll notice for the rest of them, I won't include plus c in my calculations because it will always cancel out. So c is not necessary for finding your definite integral, only when you're trying to find the actual equation. Okay, let's continue to practice. So to find the definite integral of this guy right here, we first need to find our integral equation. So go ahead and find just the integral of 14 dt. So the integral of 14 dt would be 14t plus c, but we don't need it in order to evaluate. So our next job is to evaluate. I'm just going to write this guy, 14t from 3 to 6, which means I need to plug in 6 for my unknown, and then subtract out when I plug in 3. Go ahead and find that value. We end up getting 14 times 3, or in other words, 42. All right, next one. Again, we need to first find the equation for the integral of just x cubed dx. Go ahead and find that one on your own. The integral of x cubed would be 1/4 x to the 4th plus c. We're going to continue with plus c just because it is important to remember, so we'll just continue to remember it. Okay, so then our next step is to evaluate this guy from -1 to 1. Which I think you can do on your own. Remember that we plug in this first, this top value first. So you get 1/4 times 1 to the 4th power. And then we subtract out this second x value plugged in, which ends up being 1/4 times 1, which is 1/4, minus, and then -1 to the 4th power becomes +1. So it becomes +1/4. So subtracting +1/4, and the value is just 0. For symmetric equations, equations that are symmetric across the y-axis and your bounds that are also symmetric, think about it in regards to what is going on. That it's not symmetric across the y-axis, sorry. It's symmetric across the line y equals x, but it looks like this. And so if you have this area right here, which is actually equal to this area right here, that this area would cancel out with this negative area. So that's why you would get 0, is because it's balancing out areas in the negative and the